Good afternoon. Welcome to the Friday Forum for June 10th, 2022. I'm your host, Dr. Keith Porter, Chief Engineer at the Institute for Catastrophic Loss Reduction. This is one in a monthly webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research related to ICLR's mission to make Canada more disaster resilient. Today, two esteemed colleagues will answer the question, what caused the Lytton Wildfire disaster? Our speakers are Dr. Jack Cohen, retired research physical scientist at the U.S. Forest Service, and Alan Westhaver, who runs ForestWise Environmental Consulting Limited. Our format is 90 minutes. Our speakers will speak for about half of that time, and then I will moderate questions and answers afterwards. Feel free to enter your questions in the Q&A box at any time, and we'll have the speakers respond to them when they finish their presentation. And with that, let me hand it over to our speakers. Thank you so much, gentlemen. Take it away.
Thanks for your kind introduction, Keith, and welcome everyone. Thanks for your interest in this topic and for joining us today. I want to draw your attention to the title of today's presentation, particularly the phrase, a structure ignition problem. This is a different way of thinking about the wildland-urban fire disaster, and it may surprise some of you. We'll be interested in your reaction to that later on. As Keith mentioned, we will be taking your questions and hoping for a good discussion at the end of our slides. First, though, we want to begin by acknowledging Kelsey Winter and the BC Fire Smart Committee for their sponsorship of the examination of Lytton wildlands, for instigating that, and also to express our thanks to the ongoing and strong support that we receive from ICLR, the Institute for Catastrophic Loss Reduction, support for research, education, and of course, risk mitigation. So late in July, in the wake of the Lytton disaster, Jack and I were given three interesting challenges by the BC Fire Smart Committee. Those were, go to Lytton, learn what you can about the wildfire conditions, how homes ignited, and how this event turned into the destruction of 3 Lytton area communities. Second, in a report and through presentations, communicate widely the common denominators between the Lytton disaster and other wildland-urban fires, and the fundamental ways that any community could become fire resilient. Last, make recommendations specific for rebuilding and maintaining a fire resilient Lytton community. To do this, we traveled to Lytton in early August and spent 5 days examining the wildfire that burned on the perimeter of Lytton communities, the communities themselves, and the few surviving homes, very few. Kelly Johnson of Fire Smart Canada and Brendan Mercer of the First Nations Emergency Services Society joined us during the fieldwork. During that time, we were fortunate enough to interview several first responders to the incident, and we spent weeks afterwards gathering and analyzing timestamp images, both video and photographic and aerial images from many sources. And of course, we consulted and drew from the existing science and other similar investigations. Go ahead, Jack, please. This will be a busy session. So here's a bit of a roadmap to orient you. Overall, we'll progress from general wildland-urban fire principles to the specifics of the Lytton destruction. And importantly, we begin by introducing the science basis of how structures ignite and how wildland-urban fire disasters evolve. Then we'll explain what we learned about the wildfire that occurred at Lytton and how it quickly exposed the community. From there, we'll describe the ignition of Lytton homes and businesses and how that was the result of local conditions, an area we call the home or structure ignition zone, that is, the building itself and 30 meters around them. We'll close with a discussion of the opportunities for preventing structure ignition and avoiding wildland-urban fire disasters. and provide a summary of the recommendations that we prepared for the Lytton authorities for rebuilding. And with that, I'll pass it over to you, Jack Cohen.
Thank you, Alan. Well, to start with, we need to understand that wildland fire is not just a threat to be eliminated and controlled. Our focus is typically on home destruction and community disasters. So for successful management of inevitable wildland fire, and I want to emphasize inevitable as a descriptor of wildland fire. And I want to emphasize that when we say inevitable, basically we don't have a choice over whether we have wildland fire, and wildfires are part of that, but we can choose how that and when that wildland fire occurs. So we need to recognize that fire is a natural disturbance, that is, restoring fire as an appropriate ecological process, resulting in fire resilient landscapes. And simultaneously, we need to recognize wildland fire as a natural hazard, that is, preventing disastrous community fire destruction, resulting in fire adapted communities. Well, so natural disturbance, available science has revealed that European discovery and settlement in North America significantly reduced wildland fire area burned as a sustaining ecological factor for most landscapes. Let me emphasize that these were not controlled burns. These were fires ignited by First Peoples as well as lightning and freely burned across the landscapes. So over a century of wildfire suppression has largely eliminated wildland fire as an appropriate ecological factor, resulting in a condition called the wildfire paradox. That is, our attempted exclusion of inevitable wildfire has increased the potential for extreme wildfire conditions over extensive areas. So in order to manage wildland fire as a natural disturbance, we need to accept wildland fire as an inevitable, appropriate, and essential ecological process requiring restoration at landscape scales of all fire regimes, not just low intensity fire that we tend to be comfortable with and perceive as being under control, but also high intensity fire. So this poses a profound conundrum to us. This raises the question of how wildland fire is an appropriate ecological factor across landscape scales without burning up our communities. Well, in this presentation, we will address inevitable wildland fire as a community threat, a natural hazard, and in that, we will be discussing the Lytton wildfire disaster as a principal topic. But before we get there, we need to first establish how structures ignite during extreme wildfires to better understand how the Lytton wildfire disaster occurred. That is, it is our perception that the Lytton wildfire disaster has been perceived as an extremely unusual event tied to the record Canadian high temperature the day before in Lytton. As necessarily the case. What we want to show is how the Lytton wildfire disaster actually followed the same patterns of destruction as all other wildland-urban fire disasters. And during that, we will show how wildland fire can be both a natural disturbance and at the same time prevent community wildfire disasters. So let's start with our discovery process on how homes ignite during wildland-urban fire disasters. So when we see this scene, can you explain this unusual pattern of destruction? This is exactly the question that I got right after the campfire that was accompanied by the destruction of Paradise, California. And my response to this was immediately, this is the typical pattern of destruction. So when we look at a scene like this, commonly people see the destruction without seeing the rest. Typical patterns of wildland-urban fire destruction do not support high-intensity wildfire flames sweeping through communities. And in fact, the total destruction in this scene occurred more than 4 hours after wildfire activity ceased near the community. And when we look at this scene from Los Alamos in 2000, this total home destruction was ignited by flame contact of low-intensity surface fire spreading to the homes. In fact, look towards the background, towards the middle of the scene, particularly in the right photo, there's a split rail fence where this low-intensity fire burned under the fence to make contact, spreading continuously with the house, and yet didn't ignite the split rail fence, and certainly wasn't high intensity. Well, let's take a look at this area of destruction during the burning. So here we see a video. Homes are burning hours after the wildfire passed the community. The intense wildfire never spread to this residential area in Los Alamos. And we're looking at houses burning through not burning and unconsumed tree canopies. By the way, this video was taken by the helicopter pilot. He was moving both his stick as well as the joystick on the camera. So in essence, what we're seeing here is essentially the community burning by the continuation of houses burning. So the unconsumed tree canopies amid the total destruction of these homes indicate that wildfire flames did not spread through the community. Burning trees did not ignite the homes. They're still there. And the trees that did consume were trees that ignited from the burning homes. So although initiated by wildfires, wildfires do not spread through communities. Community fuels, the structures and the vegetation within the community continue fire spread within that community. The community burns without the wildfire. So how is this happening? What is it about the physical reality that we're not perceiving or misperceiving? Well, let's start with combustion and the requirements for combustion, the fuel, the heat, and in our cases of wildland fire, oxygen may not be sufficient for efficient burning, but it's always available. Oxygen is always available for combustion to occur. So that means that combustion is a process, and it occurs right at the fuel surface. So fire is not a thing that independently travels from place to place like tsunamis, floods, and earthquakes. Fire requires a sustained sufficiency of fuel and heat for an ignition to occur and for sustained combustion right at the fuel surface. And fire spreads when ignition requirements are met locally at adjacent fuels in a stepwise process, including extreme wildfires. So because fuel discontinuities, intense wildfire flame fronts, do not spread into and through the communities. One of the things that all of us in wildfire management and suppression realize is that fuel breaks principally change the fire behavior in wildland fuels within that treatment. However, fire spread does not necessarily stop. And the fire behavior with that fuel treatment is not necessarily always suppressible, always controllable. Well, let's take a look at an example. Here we have a residential area. The crown fire, the high intensity canopy fire, spreads to the first residential street on the perimeter of this community. The structures on the right side of the road are inside the canopy that's burning. They're having flame contact within the high intensity burning. But just across 12 meters of road gap, it's not capable of spreading, igniting and spreading into the canopy of trees on the other side. However, total home destruction occurred without the crown fire for another 2.5 blocks until it ran out of structures. So what caused the ignitions? What initiated ignitions across that road? Burning embers. So that means we need to discuss burning embers as the principal ignition mechanism for communities. So let's take a look at one demonstration experiment that we did at the Insurance Institute for Business and Home Safety Research Center in North Carolina, US. So here we have a full-size house, and on the right side, we have Ember generators. We can put a blizzard, a realistic short-term blizzard of burning embers on this structure. And in this case, we have PVC plastic rain gutters with pine needle debris in the gutters. We have an aluminum segment of rain gutters full of pine needles, and we have another similar PVC rain gutter. We have pine needle debris in the roof valley of this fiberglass asphalt composition shingle covered roof. We have pine needle debris within 1.5 meters of the walls, as well as bark mulch. On one half of the front side, we have vinyl siding, we have fiber cement siding, a brand name would be Hardy Plank, and then we have fiber composition board like masonite on that reentrant corner, on the inside corner. Let's take a look at this exposure. There is no flame exposure on this structure. We can imagine the wildfire, the intense wildfire flame front as being far enough away to where it is not affecting humans, but it's affecting this home site by the burning embers that within 20 seconds ignites the pine needles next to the house, as well as pine needles in the gutter. And we can see the flow of the pine needles as it goes across the roof. And it's hard to see, but the pine needles are hitting the wall. There's a neutral or a still area, and the pine needles the burning embers hit the wall and fall down into the pine needle debris that's been oven dried before placement. So all of this flame contact on the structure is not from high intensity flame exposure, it's from burning ember initiation of ignitions. Within 2 minutes, this home, full-size home with this kind of flame contact only due to burning debris ignites sustainably. So the burning roof on the composition shingles is not a problem other than the damage that it does. And we suppressed the fire because our goal was not to burn the house. It was to demonstrate, to experiment with debris being a principal destructive mechanism from burning embers. Well, so once we initiate ignitions such as what you saw previously, the residential fuels within the community, burning structures and adjacent vegetation are the significant sources of burning embers that then continues community fire spread hours and with lower intensity, houses can be burning even 24 to 48 hours later after the wildfires completely ceased its exposure. So let's take a look at burning embers generated by burning homes. And what we're seeing here in this video, hello, and here we go. So what we're seeing in this scene are two houses burning, generating these burning embers. This, as it turns out, is the night and next morning. I'm going to go back so that you can get a sense. It's not real clear to me what's going on here with this video. Well, let's move on. Let's see what happens. So this is actually in the last night. This is Southern California, very steady winds for the last 5 days. So we're not seeing long-range ember lofting, but the size of the embers due to the burning houses are considerably larger in many cases than what you would see from a canopy ignition. So when we see a scene like this, we're seeing a burning house within green forest canopy. We're seeing surface fire that either spread to the house or the house directly ignited from burning embers. And what we're seeing here is essentially the requirements for combustion being met very locally to the structure, either immediately surrounding the structure or the structure directly. And that means that creating an insufficient fuel and heat at the structures can prevent community fire destruction. So with that, wildland-urban fire is determined by ignition conditions local to structures, and that should change our perspective. So now, the fuel is not the vegetative fuel of the wildland, it's now the homes and structures. And the heat source are the burning embers and flaming materials on and adjacent to structures. And as before, oxygen is always sufficient to sustain the initiation of ignitions and initial burning. Well, so that means that wildland-urban fire is a structure problem, not a wildfire control problem. Why? Because when we look at this in terms of mitigating risk to communities, it is the structure ignition that we have most choice over. The wildfire is inevitable, meaning we have no choice about having the wildfire, and thus the extreme wildfire is inevitable. Our choices are with the structure ignition vulnerability, not with the wildfire. Well, so what we see from these scenes is that intense simultaneous community heating from wildfire flames does not occur. It's the local conditions that determine home ignitions. And that raises the question, well, within what distance are conditions considered local? And that brought in the research that I principally did 30 years ago that defines local using modeling experiments and disaster examinations, the results of which revealed that a home in relation to burning materials within 30 meters of the home and within 30 meters principally determines home ignitions during extreme wildfires. Typical extreme wildfire flames are not sufficient for wood ignition beyond 30 meters. Given burning embers, ignitions are determined by embers accumulating on a home's flammable materials. And this area is called the home ignition zone, or the HIZ. And diagrammatically, this organizes and puts dimensions on what the characteristics of the HIZ are. It organizes and scales this local condition. So from this, we can take away that in this scene, total destruction was not indicative of high intensity wildfire exposure. Without available protection, small ignitions result in total destruction, which is the case in this particular scene. So we can take away with the idea of the requirements for combustion, sufficient heat and fuel. Local HIZ conditions were not sufficient for home ignition, and wildfire suppression was not necessary. In this particular case, local HIZ conditions were sufficient for home ignition, and structure protection was not available. So HIZ conditions, home ignition vulnerability in relation to burning embers and burning materials within the HIZ determined these results. Well, so now let's take those results, what we've learned from past research, and apply it to the Lytton wildfire disaster. So let's examine the Lytton community fire disaster and recognize that local HIZ conditions determine the structure ignitions resulting in the total destruction. So the Lytton community destruction exhibited the same general pattern of destruction of adjacent unconsumed vegetation. And within the dashed ovals, we can see that unconsumed vegetation that clearly did not contribute to the destruction and initiation of ignitions within Lytton. And we can see an example, a parallel example in a previous US fire called the Tubbs Fire in 2017. So, wildfire behavior at the Lytton community can be described as extreme. Neither high intensity fire spreading through tree canopies, a crown fire, nor significant canopy torching occurred, however. When we look at this scene again, surface fire without canopy burning was what initiated the ignitions. So extreme surface fire burning through grass, forest litter, and light shrubs rapidly spread to and along Lytton community boundaries. Let's take a look at an example of what that would be. This is not Lytton. But this is a grass and light shrub fire. All of these ignitions in this scene were from burning embers, spot fires from burning embers. And within 1 minute, we will see these spot fires rapidly spread and coalesce into separate flame fronts. Although this is not a crown fire, it's a grass fire on the surface. The intensity and the rapid growth of this fire can be considered extreme. It will definitely overwhelm wildfire suppression and control. So a profusion of burning embers ignited spot fires across short distance vegetation gaps to continue rapid fire spread in Lytton. A ground blizzard of burning embers, similar to what you see in this scene, is what initiated the Lytton community ignitions, meaning we cannot expect effective wildfire suppression for inevitable extreme wildfire behavior. So let's take a look at how wildfire spread at the Lytton community. After burning in a basin area between the railroad tracks and the village of Lytton, wildfire rapidly spread simultaneously along 4 independent paths at the edges of the community. So here we see fire in the basin, B in yellow, lower left, and one of the spread paths was up along the west side of the village of Lytton into IR-18, and we see that fire spread independently into the southern portion of the village of Lytton, and simultaneously it was spreading up the east side of the village of Lytton, and then the 4th spread path spread into IR-17. Well, let's take a look at, based on observed wildfire locations, the timing of those spread paths. So the wildfire was reported at 4:38 in the afternoon in the basin. At 4:54, wildfire was observed spreading along the railroad tracks east of structures on Main and 2nd Street. And we can see the fire behind the Rest Motel at 4:54. At 5:09, wildfire burning on the west side of Highway 1 was across from IR-17. And we can see that photo taken from a vehicle on Highway 1. Then at 5:16, structure fire was observed at the south end of Fraser Street in the village of Lytton. At 5:18, wildfire was observed across Highway 1 at the west side of IR-17. And then at 5:20, wildfire was observed in the very southern portion of IR-18. What that means is that within 40 minutes, fire had initiated ignitions either in vegetation within the community or structures themselves, and overwhelmed fire protection, structure fire protection. So the ignition and burning of the Lytton community was primarily surface fire and burning embers initiated, widely dispersed, multiple ignitions along the perimeters of the village of Lytton, IR-18 and IR-17 within 1 hour of the reported wildfire. So we have aerial photos starting at 6 in the afternoon, less than 1.5 hours of the reported wildfire, where there are more than 20 primary structures, homes and businesses, simultaneously burning. We see that in the village of Lytton, both on the west and east side, as well as the south side, following the spread paths, as well as up in IR-18 and 5 structures involved in IR-17. So based on the National Fire Protection Association, U.S. Fire Protection Association 1710, the guidelines for effective structure fire response, we can ask the question, what structure fire protection would have been required to limit fire burning in the structures at 6 p.m. So the guidelines indicate 3 urban engines, type 1s and type 2s, and 12 to 15 firefighters per structure. More than 20, but 20 fully involved structures translates to 60 urban engines and 240, 300 firefighters within an hour and a half. Very unrealistic response for almost all communities in North America. So the maximum reasonable structure protection availability would have been overwhelmed. What that means is that during this extreme wildfire spread and behavior, rapidly initiating structure ignitions, our emergency response will be overwhelmed. So what expectations do we have for wildland and structure firefighting effectiveness? Well, during extreme wildfire conditions, a reasonable maximum wildfire suppression response will be overwhelmed. And during extreme wildland urban fire conditions, a reasonable maximum structure protection response for ignition vulnerable communities. And let me emphasize that descriptor, ignition vulnerable communities, that will also be overwhelmed. So let's take a look at the Lytton community burning at 6 p.m. and particularly look at IR-17 and the 5 houses involved up there that were eventually totally destroyed. We're focusing in now on that area. Wildfire was observed across the highway between 509 and 518. We have a fully involved house that's not on either end. It's in the middle. It's the one that is most involved at this point. And then spreading upwind into the house next door, we see a burning shed, not a house at this point, with the next house to the south. There is a burning shed and the beginning of full involvement of that house. And on the far south end, we see an ignited house. Then we can follow that time sequence, recognizing the labels on the structures A, B, C, D, and E from south to north. So wildfire had initiated community ignitions and burned out before PM. There is no wildfire activity, significant activity in this scene at 6. So at 6, structure ignition and burning has occurred at all 5 home sites. At 6:13, houses A, C, and E are fully involved. House D has largely consumed. Sheds at B and E have also largely consumed. Then, a half an hour later, roughly, houses A, C, D, and E have largely consumed. House B may have ignited, we can't tell from this scene, but burning is not evident. Only the shed was evident to be burning in that case. Well, so what does IR-17 burning provide us? What does it tell us? After the wildfire initiated residential property ignitions, homes burned independently of wildfire influence. All the houses showing ignition at 6 p.m. had largely consumed by 6:29. Homes largely consumed in about 40 minutes. And this is consistent with what prior examinations of extreme wildland-urban interface fires, wildland-urban fires have indicated. Structure ignitions, homes and sheds were determined by the local home ignition zone conditions of the structures and their immediate surroundings. So in summary, the wildfire did not spread through the community, igniting each structure. Rapidly spreading extreme wildfire initiated nearly simultaneous ignitions extensively across the community perimeters. Burning materials, structures, and other flammables within the community continued fire spread and structure ignitions well after wildfire had burned out at the community perimeters. Structure ignitions were determined by the local home ignition zone conditions. The Lytton community fire disaster had the same general conditions leading to destruction as other wildland-urban fire disasters. So, how do wildland-urban fire disasters occur? What is the sequence? that leads to this disaster? Well, let's start with severe fire conditions. The fuel, in this case, the vegetation, the weather, and the topography, given an ignition, generates a wildland fire with rapid growth, potentially rapid fire spread, but rapid growth due to burning embers generating spot ignitions in advance of the spreading flame zone, and high intensity, potentially. But importantly, even with surface fuels like grass, the intensity still overwhelms direct suppression actions. Then, given ignition vulnerable structures, there are multiple simultaneous community ignitions that overwhelms structure fire protection resources. Too many homes, not enough resources can engage. Many homes go unprotected with no attention. Any sustained ignition then produces total destruction. Multiple homes totally destroyed produces the disaster. So we have extreme wildfire. What we've seen is that wildfire control during extreme wildfire behavior fails during wildland-urban fire disasters. Whether it's high intensity crown fire and high growth rate from spot ignitions, then in a continuous forest canopy, or medium intensity surface fire, rapid flame spread and growth rates with spot fires in grass and light shrubs. So given extreme wildfire, where might be our choice? Well, as we've seen, local conditions produce the fires within the home ignition zone, and we have a choice over the vulnerability of those homes. So what if homes don't ignite and burn? Then our structure protection resources are not overwhelmed. Homes do not go unattended, and we've prevented the disaster. So is this possible? Can we prevent homes and other structures from burning during extreme wildfires and effectively prevent wildland-urban fire disasters? And the answer is resoundingly yes, of course. The local home ignition zone conditions principally determine structure ignitions, and those conditions can be readily mitigated to create ignition-resistant homes and collectively ignition-resistant communities. So what does an ignition-resistant home ignition zone look like? When we've eliminated most ignitions by having no high-intensity burning within the home ignition zone, structures or vegetation, high-intensity wildfire that might be spreading to ignition zones ceases in zone 2, not necessarily by removing all vegetation, but as we saw, if we have discontinuities between the canopies of conifer trees, we can then disrupt that continuous spread. So we also can produce low intensity fire that can occur in zones 1 and 2 with no flame contact or long duration burning to expose the house. That is long duration burning of sheds and wood piles and such, and the neighbor's next door house, especially in zone 1. The primary structure includes flammable attachments. So when we look at this structure, we're also including all flammable attachments like decks and boardwalks. Nothing burns within 1.5 meters. We call it the non-combustion zone. It doesn't necessarily have to be devoid of all vegetation, but it has to be devoid of anything that can support combustion. So that doesn't include the foliage on your roses, but it does include that bark mulch or those pine needles on the surface. wildfire and community sources of burning embers are then become the only ignition exposure to homes and structures within the community. Mitigating structure ignitions involves the building materials and the design. The inside flammable corners are the vulnerable locations for direct ignitions of the structure. Well, so what about overlapping shared home ignition zones? High density community development has been a common situation in recent wildland-urban fire disasters. The village of Lytton was such a case. So when we look at the home ignition zone and we see how large it is, it's on the order of half a hectare. So when we see that and plot it out in Lytton, we see that an entire block is roughly the home ignition zone. So the requirements for ignition and combustion don't change. The physics stays the same, but the social dynamics changes dramatically. And that requires need for property owner cooperation. Structures separated by less than 10 meters can produce structure-to-structure flame spread, and all properties within shared home ignition zones require high-level ignition resistance to reduce everyone's fire risk. We need to realize that ignition resistance is not fireproof. We need to reduce potential structure-to-structure fire spread in addition to ignition resistance. Technically, we are addressing two separate kinds of requirements for combustion, one of which is ignition performance, reducing the ignition vulnerabilities. And then if we do get an ignition on a house, we also, in this high density shared home ignition zone situation, we also need to address fire spread performance and reduce that. Well, let's take a look at an example of a surviving house in the village of Lytton to give us a clue about how we might do that, how we might increase the fire spread performance of the community. So here we have this house that survived with the adjacent homes north and south of it having totally been destroyed. So let's take a closer look. In this particular case, the surviving house is the X house. House to the south that was destroyed is S, north N, and then the burning structures across South Fraser Street are labeled E as being the E structures. So at 6 p.m., we see that the house S on the south of X is burning, and there is vigorous burning with heavy involvement of the E structures across the street. At 6:13, house S has largely consumed. Structures E across the street are even more involved and intense, and house N shows smoke coming from the north side of the house, but it's not yet fully involved. And then at 6:29, we see that house S has largely collapsed and is not burning, it's largely consumed. House N on the north side is heavily involved, and the E structures, the intensity is waning. So how did house X survive? When we examine, what we found is that on both sides of house X that had vinyl siding, the house on the north and the south had masonry stucco that remained the wall structure, the external surface, until the structure collapsed and drew the exterior stucco in over the burning material. The same thing happened on house north side. We're looking at very small property line setbacks. So the non-flammable stucco and the non-flammable stucco on both sides kept this house from sustainably igniting. That stucco sufficient house X from flame radiation to prevent the ignition. Well, so what about the burning of the E structures? We see that they lasted sufficiently on the order of 20 minutes, intensely burning. What did that mean in terms of exposure? And what we saw was damage to the vinyl. Well, let me go back. But vinyl damages at temperatures far below those associated with the requirements for combustion. So we get damage on the vinyl. We got significant damage, particularly from the north side house on this structure, but it survived because it was ignition resistant and is resistant to structure spread. And now our recommendations. Alan.
Thanks, Jack. Well done. Switching now to our report recommendations, and I want to mention that our report is available in its entirety on the ICLR website. You'll find that those recommendations are tailored to the Lytton fire situation, but they're also meant to be applicable to all communities in wildfire-prone areas. So the recommendations are broadly and widely applicable. We began by making 4 strategic recommendations. Basically, this is what needs to happen. And essentially, we're advocating for a shift in priorities away from disaster response and towards wildland-urban fire risk mitigation activity. Those overarching recommendations can be summed up in a single statement. It's here on the screen. The strategic wildland-urban fire priority for Lytton community residents, businesses, authorities, and operational staff should be taking actions to reduce the ignition vulnerability and ignition exposure within 30 meters of all community structures and infrastructures. Pretty simple. In turn, those core perspectives were built into all of the more tangible operational recommendations, which we broke down into 7 distinct categories, which address how improvements can be made. And the first group of those, go ahead, Jack, is dealing with reconstruction and the safe return of residents. And first and foremost, our emphasis is to tackle the root problem, the easily ignited homes, by prioritizing onto reducing the ignition potential of those structures. And of course, to do that, the funding and the resourcing must follow that priority. It's mostly little things that make a big difference, but they do add up. And as Jack has shown, this is the pathway to fire resistance. We need, secondly, to concentrate on the home ignition zone, make that the primary unit of our work. And thirdly, to utilize the national, we're on 1C here, to utilize the National Guide for Wildland-Urban Interface Fires, a new document published by the National Research Council of Canada, which contains all of the current guidelines. And with regards to Lytton, to initiate in 2022 an annual program to manage the light grassy fuels which are building up to sustain the next wildfire. The second group of recommendations I believe to be the keystone for success, and that is to the active engagement of fire authorities with the community and resulting in the active community participation. And this is going far beyond awareness and education too. And when we say active participation, we mean the rolling up your sleeves kind of participation by all stakeholders and residents working in collaboration with fire authorities. And as Jack has shown, Fire Smart needs to be not isolated homes, but it needs to be throughout the community. It is a team sport. So we recommend 2 time-tested and proven tools. The first being establishing what we call the Wildland-Urban Steering Team, a group of a forum for all stakeholders to participate in discussions, decisions, collaboration, and coordinating the actions throughout the community to ensure a fire resilient community. The second is to implement the Fire Smart Canada Neighborhood Recognition Program. It is the one and only and successful program for mobilizing whole neighborhoods of people to work together to inch by inch, action by action, become more fire resistant. And of course, that requires that fire departments staff and resource themselves to facilitate with people that can facilitate those initiatives. The third group is bylaws, regulatory mechanisms, and we advocate that those approaches be used to best advantage and create baseline conditions throughout the community through amendments to existing regulations and bylaws by, in some cases, selected mitigations that are mandated. And as examples, I would suggest maybe non-combustible roofing and widespread implementation of the 0 to 1.5 non-combustion zone that Jack identified. And if it's necessary, if the collaboration can't be gained, I think some municipalities should explore the means of compelling compliance for vegetation management on private and corporate lands. But I think collaboration is the way to go. The fourth group of recommendations deal with how do we manage lands within the corporate boundaries of towns, villages, and cities. And Lytton was no exception. It's peppered with areas that are vacant public land, but do contain fuels which allow advancement, of progression of fire. So things that can and should be done are take procedural actions to simplify approval or permission for residents to work within their hazard ignition zone, but beyond their property lines. Enable and ensure that there is periodic reduction of woody fuels on public and private corporate lands that contributes to the problem. And again, municipalities need to provide the resources, physical and fiscal resources for doing those kinds of mitigations and working in collaboration with residents. The next category pertains to community infrastructure. If a community loses its infrastructure, it's much more difficult to recover. And 2 recommendations here. First and foremost is the importance of a reliable domestic and emergency water supplies and delivery systems. And the second is that municipalities identify their critical infrastructure, assess the risks, and mitigate those. Category 6 is emergency response. And as Jack highlighted there, it's important, assuming a fire-resistant community, to equip and staff those fire departments for highly mobile, rapid initial response to the few spot fires and structure ignitions that will still be occurring. And finally, to look at the bigger picture and do everything that we can, both on a local and a provincial basis, to encourage prescribed burning and modified response to wildfires as means of reducing the fuel load and the wildfire intensity on neighboring lands. So that brings us to the close, and we'd like to close by offering a new slogan for promoting fire smart programs across the country. It might read something like making our homes and communities ignition resistant means having wildfires without wildland-urban fire disasters. So that brings around the opportunity for questions, discussion, and we thank you very much for attending.
Awesome. Thank you so much, gentlemen, for a strong argument supported by plenty of clearly presented photographic evidence. There are a few questions. First, Fred Lagasse asks, Alan, do you think the same recommendations are being followed in Fort McMurray?
I think the recommendations are equally applicable. I don't know for certain, but we do know from work that's been done recent work by the Canadian Forest Service that there are over 62,000 wildland, what they called wildland-urban interface communities that are in the wildfire-prone areas that are susceptible to this problem, and they all need to be looking at these recommendations and, the understanding the basic principles.
Great. Brian McIntosh asks you, Alan, curious if you have the CFF SRS indices on the day of ignition, BUI, DC, ISI, and FWI, and would you mind translating those acronyms?
Okay, so thanks, Brian. Hello again. No, we did not bother with quoting the wildfire behavior indices. They were all in the extreme range, and that's the fact. Whether it was a 30-day event or a 2-day event, that's the common factor in these kinds of events. We have extreme fire behavior, and we have susceptible structures. And generally speaking, when we say extreme, it means windy conditions and very dry fuels. So once we get into high fire danger and beyond, the pump is primed.
Cool. Masood Adelzadeh asks 4 questions. Masood, if you don't mind, I'm gonna read your first, then I'm gonna go on to Michael Curry's question. And then if there's no more questions, I'll come back to your second, third, and fourth. So how did the roof's asphalt shingles perform? Were walls more vulnerable than roofs?
Jack.
In the village of Lytton, well, let me start off by saying one of the characteristics of communities burning down, and specifically a house, is that, let's start with the fact that if there is any sustained ignition on a house during these kinds of extreme conditions, and particularly with regard to the simultaneous exposure to vulnerable houses, any sustained ignition results in heavy fire involvement of the structure, and during those situations, total destruction. So what is more vulnerable? Well, if you have flame contact and you have a flammable material and design situation on a structure, it's not the walls, it's the junctions of the flammable wall material with flammable horizontal surfaces or near horizontal surfaces. Most of the structures in Lytton had a non-ignitable roof covering, which would be asphalt composition shingles. So one of the things that I've found in the research that I've done is that both in terms of laboratory experiments as well as full-scale field experiments and disaster examinations, composition shingle roofs are highly ignition. Well, they're ignition resistant in the context of a wildfire exposure such that they don't ignite. Burning debris on them don't penetrate. And even during extreme fire involvement, the roof doesn't carry fire away from a location of penetration, of fire penetration. Okay, so the question was, what's more vulnerable? Well, they're both, particularly with anything other than flammable wood covering, they're both highly resistant. So you can have wood walls. What you can't have is flammable inside corners with those wood walls, or flame contact from other burning material surrounding the structure. The kind of the bottom line is burning embers don't accumulate on vertical surfaces.
Cool. Let's see.
Keith, I might just add a little bit to that
Sure.
answer.
Yep.
To Masood's question is that conducting a post-fire assessment, it's really pretty well impossible to tell where those ignitions began and where the actual vulnerabilities occurred that led to the ignition of a particular structure. But we are promoting a research methodology that would allow us to attend fires before the home ignitions and record some of those conditions and perhaps even observe where those ignitions come. So in essence, using one of these incidents as an experiment and to test those hypotheses and know more in a real situation. So that's a coming publication of ICLR.
Cool. Michael Curry asks, would in-advance application of long-term fire retardants in high-risk grass and shrub areas be a recommended effective approach to limiting possible ignitions and rapid fire spread through an area such as Lytton?
So this is an issue that I worked with to some extent with fire retardant companies who want to expand their retardant use to local areas and particularly around houses. First of all, let's recognize that it's called fire retardant, not fire extinguishment, which means that it typically changes after application and particularly after it dries out and becomes then a coating, primarily an diammonium phosphate coating on that potential vegetative fuel. What it does is it modifies the fire behavior. It doesn't necessarily stop the fire, but it stops the fire behavior from being rapid spreading with flames. So what that does for the house is it tends to reduce any flame contact that might occur to the house from areas beyond the 1.5 meter zone. What it doesn't do is stop any burning embers from landing and accumulating on the house, under the house, or through open areas into the house. So one of the messages that this sends is that yes, there are potential multiple ways of keeping flames from contacting the structure, principally in zone 1, which is 1.5 to 10 meters from the house. But that can be done passively, more reliably than active intervention, either from water, sprinkler systems, or from retardant. And oh, by the way, mowing your cured grass down to 2 inches of the surface is considerably cheaper than spraying fire retardant around your house, and particularly the effects potentially of diammonium phosphate running off into aquatic zones.
Great. Al Beaver asks, could you kindly comment on how dangerous the urban fire environment is for fire response resources to operate, even if we had unlimited resources?
Hello, Al.
Yeah.
We work
Well,
together. And
that's a great question. And when you think of the disaster sequence there, it brings in, into perspective that In all of these situations, triage takes place and there are decisions to be made as to where resources go and where they do not. And a primary decision point in all of those situations is the safety of firefighters. And by and large, there are many situations and conditions that make it unsafe to send firefighters even if we have them. And I've seen examples of those occurring fairly widespread in Fort McMurray, and probably were occurring in Lytton as well. Sometimes it's due to the design of the community and the accessibility and escape zones and escape routes, but also it's just merely the overpowering heat of fires. And even our firefighters are more susceptible to that than wood walls.
Let me add to that by saying that in order to be mobile, highly mobile with distributed water, we do not recommend anybody being in bunker gear in turnouts, the heavy structure protection bunker gear, which means that you're wearing essentially wildland Nomex PPE. Plus, we're not using breathing apparatus. And when structures begin to burn, you should not be anywhere around the smoke column that comes out of the burning structure. It's full of all kinds of toxins. So for example, in that demonstration that we did in the research center, one half of the walls was clad with vinyl siding. That vinyl siding, when it was burning, produced hydrogen chloride gas. The firefighters that supported us were all in breathing apparatus. What you didn't see in perhaps with the personnel were those that were tending the burning Ember generators. And no, they didn't have. And oh, by the way, they were upwind within the laboratory. But when the fire was suppressed, and particularly inside, all the responders were in bunker gear and breathing apparatus. So that is a significant impediment if once we get heavily involved structures within a community, we begin to have to disengage the highly mobile resources that have a little bit of water to pick up the very small ignitions before structure involvement. So what that says, and this was not mentioned, because homes cannot be fireproofed, that doesn't do away with our fire responders. What it does, ignition resistant communities enable effective fire response. It doesn't do away with fire response.
Awesome. Ernesto Rodriguez asks two questions. I'm going to relay the first one, and if there's time, we'll come back to a second one. He asks, how can a municipality identify the level of vulnerability to wildland-urban fires and determine its level of participation in the Fire Smart program?
Well, so one of the things in the US that's going on is the characterization of wildfire conditions, particularly with regard to wildfire intensity. What this does for us, the mapping of wildfire potential, is it identifies priority areas to look at. So in other words, we don't have the assessment availability such that we can do everywhere. It's not a very expensive engagement, but we don't have the skilled resources to do assessments everywhere all at once. So that means we have to choose priority areas. One of the ways to assign those priority areas to assess the communities then for its ignition vulnerability is to identify the frequency and maximum potential intensity for the wildfires within, let's say, 2 kilometers of the community. And so when we look at communities, the first thing we should do is to look at the exposure potential due to wildfire. That's the hazard side. That's the hazard priority assessment side with regard to the wildfire. At which point then we can choose that high priority community based on wildfire exposure potential for its ignition vulnerability. That ignition vulnerability needs to also be accompanied by a fire structure to structure spread vulnerability with regard to its density. Okay, so when we talk about a home ignition zone, we're assessing the ignition vulnerability of the structure. Well, then what about a location like the village of Lytton, where we have overlapping home ignition zones where the property next door is out of our control, but highly impacting to our structure. So then the assessment of the disaster potential of a community looks and focuses on the ignition potential, as well as what happens when we do get a structure ignition. How can we then begin to at least slow down the fire spread within the community from a structure that was heavily involved? And again, so notice what we're doing here with regard to the emergency fire response. We're enabling them to be effective. There are 2 components then of that emergency response within a community, one of which is widely distributed, rapidly engaging for spot ignitions and small ignitions with backup from our structure protection kind of capability, which is an inundation capability. It's not highly mobile. It's essentially a lot of water delivery capability at once then to control and contain that heavily involved structure. Plus, they're also going to be their PPE, their personal protective equipment, is going to be heavy Nomex and breathing apparatus. Does that make sense? So I've bridged from ignition resistance to the reality of the effective fire response.
So I'd also like to add to that question a little bit, if you don't mind. It's a complex problem, all right, but it's one that we can't wait till the last tiny bit of analysis is done. We know enough about this problem to begin attacking it in a widespread sort of way. And it's very important that we do get to work in a lot of those 62,000 communities, you know, and not to mention that many of those have multiple neighborhoods. And there are ways of, you know, gaining that inroad and tackling the problem. We'll learn more as we go, but it's one of those problems that we shouldn't wait for the final last word of analysis. You know, there's a lot of work that is happening, but we do know enough, and there are simple systems for going into a community, looking at identifying simple things that can be attacked, and for beginning that process of becoming fire resilient.
You were looking perplexed, Keith, and so that concerns me, that I have largely confused people with, and I've sort of leaped ahead into the fire response effectiveness part of the issue. And so I want to summarize by saying the key to effective current response is ignition resistance of the home and its immediate surroundings. If we have a single house on a home ignition zone within a home ignition, then we don't have the structure to structure spread issue. At which point it is either handled or not based on its ignition vulnerability.
I think I was looking, sorry, go ahead.
No, well, and that's also true of denser communities. The addition there is what happens if we do get a structure that becomes heavily involved. Do we just give up and let it spread down the block?
Yeah, I guess I was looking perplexed because I was thinking, I think maybe you were seeing more in Ernesto's question than I was, maybe more than he meant. I think he was asking himself or you, is there a quick way for a municipality to decide, all right, well, we are or we are not vulnerable, and therefore we should or we should not participate in FireSmart, and if we do, here's how we should begin to do it. So he's asking a really, entry-level question for one of those 62,000 communities. Picture yourself on the city council of a little community, and you hear, well, we're in a fire-prone place. Kind of, what do we do about it? Do we have to participate in FireSmart? And how do I know how serious the problem is? I think maybe that was what he was.
Yeah, Keith, I can see Kelsey, if Kelsey Winter could jump up and down, I could see her wanting to answer this question for sure. And if we look at the FireSmart Canada Neighborhood Recognition Program, the first step is to contact a local fire department, and more than likely they will have or can obtain a local FireSmart representative who is trained in coming into the community and doing a rapid assessment, identifying some of the issues, and then translating that to begin working with a group of residents who are willing to start identifying solutions and tackling the problems with, once annual activities. So it's as simple as that, or it's as complex as it can be. But there's an example of, how, and all it takes is one interested person in a neighborhood, and then the word of mouth start going around and gathering people together.
So your answer is call the fire department, have them reach out to FireSmart and have them.
Or contact in British Columbia, FireSmart BC, contact FireSmart in Alberta, Ontario. They have trained people with this program. It's Canada-wide.
Cool. Thanks. Terry Balin asks, well, first he compliments your presentation. He says, well done. Great presentation, Jack and Alan. And then he asks, any thoughts on how we can get engagement in wildfire resiliency, FCNRP, in rural communities, local government, provincial government? We seem to have no problem spending millions on response and very little on prevention and mitigation.
You go, Alan. I have 30 years of failure.
Okay. Well, there is a toe in the door. I mean, changing this perception of the problem itself is got to happen, and I think that's happening. The ore is in the water, but there's a long ways to go, but I do see many communities, picking up on this. And I do agree that it's a little more difficult in rural areas where populations of people are more dispersed, but there's also encouraging things in those low density areas. Property owners, if they're living a little farther apart, they actually control a lot more of the factors that are important, a lot more of those vulnerabilities and exposures. So again, it comes down to getting the information out and using the neighborhood recognition program. And in fact, Terry Balan works in the Cranbrook Regional District of East Kootenay, which over the last 2 to 3 or 4 years has actually developed, I think, about 15 FireSmart recognition communities and groups of neighbors, even in rural areas. So it's a slow process, but it does require more of an investment. I'm not sure how much of our total investment goes into that kind of thing, but it's pretty minor at this point. I hope that ship will turn around.
Thanks. Michael Curry asks, do you anticipate inclusion of recommended prevention practices being codified in the National Fire Code so they will be enforceable and applied to the existing built environment? And he also asked whether ICLR will be making code change requests. And I'll let you answer the first part, and then I'll take a stab at the second.
Sure. Well, will it be codified into the National Building Code? I think there's others more qualified to answer that question than I, but I think the first step in that was developing the National Wildland-Urban Interface Guide and gathering that information and setting out what the standards could be. And then there will be a lengthy process involved in moving that towards integrating it into the National Building Code. And again, that takes adoption by different jurisdictions in order for it to have any force. But I believe that is the eventual intent.
Let me just add by saying that we're not going to code our way out of this issue. There are, and the reason for that is because of all the transient kinds of critical one factors that influence vulnerability. So it's going to be hard to code out patio furniture, flammable cushioned patio furniture next to our plate glass windows on a deck. It's going to be impossible to code out firewood on our deck next to our house or pine needles in our gutters. We might code the kind of gutters that you have with regard to gutter guards if they're effective, but where I think an extremely positive example of coding can be in overlapping home ignition zones to reduce or eliminate significant structure-to-structure fire spread. I think we have a greater chance of coding away high-density fire spread in communities than we do in all the various factors, maintenance kinds of factors responsible for ignition vulnerability. So
Agreed. Yeah.
Just recognize we're not going to code our way out of this problem any more than we've coded our way out of having candles burning next to our Lytton curtains or leaving a pan of oil on our going stove.
Yeah. Two other considerations are that, the vast majority of our problem is in existing communities where new construction is not necessarily an option. In retrofitting it is. And also that my observations are in places like Slave Lake and Kelowna and Fort McMurray that a high proportion of, like Jack says, the vulnerabilities come from vegetation, things that residents do that we control as property owners, the things we plant and where we plant, and their contribution to the ignition exposure and vulnerability of homes.
Mostly through debris.
Yes, debris, combustible stuff, and vegetation.
Right. And I would have taken a stab at answering the part of that question addressed to ICLR, but we are just about out of time. I want to give you, first I want to thank you gentlemen for an outstanding talk and give you the last 60 seconds for any final thoughts that you want to leave us with.
I'm done.
Just the last thought I would have is that Lytton was an extreme situation, but it was not exceptional. I think what we've learned is that all of these situations are extreme. They only happen when it's extreme, and we have to be able to deal with those circumstances. And good luck.
Thank you so much, gentlemen, and great work, great talk. I want to invite everybody back next month when Tuna Onur will be telling us about changes to the seismic provisions in the National Building Code. Thank you all for attending, and hope to see you next month. Bye-bye, everyone.
Bye now. Thank you.
Thank you. Bye, Keith.